be talking about our thermographic building energy efficiency study. My name is John Paul. My other group members are Keylon, Jorge, and Juan Jo. Let's get started. First, we must understand what building energy efficiency and building envelope is. When a building has energy efficiency, it means it enhances energy while maintaining comfort. This is done in different ways. First, insulation to reduce heat transfer, proper sizing and optimization for most efficient HVAC system, using LEDs and daylight, using smart controls for building automation, and implementing certain solar and wind for renewable energy. Building envelope is a physical barrier between the interior and the exterior of the homes. So this is the walls, the roofs, the floors. We want to create an air barrier to prevent air leakage. We want to control moisture, maintain water damage down. Windows and doors, we want to make sure they're energy efficient in design, and we will go over why in the next slide. And then a facade design, optimizing lighting and heat. So what is thermographic inspection? Thermographic inspection, or thermography, measures surface temperatures by using infrared video and still cameras. These are tools that see light that is in the heat spectrum. Images on the video or film record the temperature variations of the building's skin, ranging from white for warm and then black for cooler areas. Here we can see some of the thermal images that we captured. You can see that they are captured using the infrared thermal imaging, and images are taken on both inside and outside. Since these were public buildings, most of the pictures we took are from the outside. Bridging, as I mentioned before. Thermal bridging is essentially when the flow of heat escapes through door or window frames, essentially bypassing the insulation around the window and letting the heat escape. Talk about some findings that we saw with the thermal images that we took. On the left-hand side, you can see two different images. One is of Francis Hall, and then the other one is St. Louis Hall. As you can clearly see, Francis Hall has a lot of darker areas compared to St. Louis Hall. This is because the newer buildings have better heat retention compared to the older buildings. Another finding was a thermal anomaly that we found. Here we can see the Cudahy Science Hall. On the lower left-hand side, you can see an unexpected temperature variation. It is the hottest place, meaning that the most heat is escaping it. Here we can assume that there's an electrical issue, a plumbing leak, or maybe even just a structural defect. Thank you.